Hello and welcome to this overview of the spawning system for this Unreal asset that is currently in development. We're developing this anime character, and one of the features that it will have is these projectiles. And in today's video, we will do a little overview on how they are done and how do they work. With me here is Guillermo, our particle guy,
What's up? Hey.
and I will try to explain him as best as I can how it works. So, let's begin. First, you have to keep in mind that the projectiles are another blueprint. You have a good grasp about blueprints, right?
Yeah.
Yeah, so we have this character blueprint that is our cleric. Let me open it up. And we also have this projectile. This is the blueprint that we will spawn whenever we click and the animation plays. You have some particles here that he has added, and the blueprint is just a container for components. These are the components. We have a collision sphere, a particle system, and an actor component called projectile movement. This projectile movement already comes with Unreal and has a lot of variables we can tweak. Here we have initial speed, max speed, etc. We just have to know how to use it, so it almost does everything for us. So the first part of this is to spawn it whenever we want. For this, we want it to be synchronized with the animations. In this case, we're spawning it from the weapon, and in this second attack is from the hand. So the way we're doing this is through the same animations. I'll open the blueprint with Ctrl E, and let's find the animations used. This skeletal mesh is being driven by an animation blueprint that is here. It already comes with the asset that we're gonna be putting up in the marketplace. And the animation blueprint will call this montage. In our case, we can open the montage because here is where we can spawn the blueprint. So here it is. We have these notifies that we will use in order to have an event that can be used by blueprint. So, for example, I have this play montage notify, and I'm giving it the name of spawn projectile stuff. So this will be the event that I'm creating for the projectiles that will be spawned in the stuff. Also, because we are spawning 3 projectiles, if we return to the demo, here we have that the hand spawns 3 projectiles. What I'm doing is calling the same montage 3 times. The notify name in these 3 notifies will be the same. Hand, spawn projectile hand, and the first one will be spawn projectile stuff. How do we use these notifies? If you remember our combo, how to do a combo attack in Unreal, we are using the attack. We're creating a generic attack function that it's being called every time we click. And what this does, the core of it, is playing a montage, the animation montage, attack montage. And this node has the execution pins where we use the blend out to tell the blueprint that the attack is finished. But it also have the onNotify begin. In this case, the notify begin will only use the play montage notify. We can create this by right clicking and adding a notify. We can create a new notify that could be used in the animation blueprint, but For it to work with that node in our blueprint character, then we have to use montage notify. Clicking here will create a play montage notify that let us set up a name for the notify. So I'll delete this. Whenever the notify plays, it plays every time the animation goes through that notify, it will return this event, and I'll place a breakpoint so it's a little more graphical. Let's press play, and there it is. This first notify will be not this one, but the one below that we're using to save the previous location from the staff. I'm doing this because I wanted to create a little curve whenever we spawn the particles. So you can see the curve here. And yeah, you can see that it's not going straight. It has a little curve, but this notify does not give us that information. So what I'm doing here is, oops, I'll press pause. Yeah, here I'm saving the location of the staff, and here we will use that same location. So whenever this notify plays, what information we are using is the location here that it will probably, and if you excuse my bad drawing, let's say that the weapon was here. I'm saving this location. Let me put it in another color. I save in this location, and with this previous location, I will compare it with the current location. I will then create a vector between them. So let me change it to this color. And this is the vector that I will use in order to have a direction where the particles will spawn. So the projectile, instead of going forward, it will go in this direction. And because it's a homing missile, it will go, after some time, it will start finding the target, and that's how, whenever we press play, you can see a little debug sphere that is the target, and it doesn't matter what rotation it will have, it will start correcting its path, so it goes that way. So that curve is being created by saving a previous location and using the current location to create a vector between it, and there you have the direction. So the first notify will check that, and I'm only asking here what's the name of the notify. So in this case, this node has fired because it's blinking, and we can check the value by putting our mouse over it. In this case, the value is save previous location staff. Here I'm doing a comparison if to this name that it's currently save previous location staff with the same value. So this will return true. If we press F10, we will see that we're only saving a location. I'm getting the socket location of this specific socket. This socket is returning, well, it will return this location and save it in the previous socket location. And just in case you don't know how to set up sockets, we just need to go to the skeleton, and here we can find the parent skeleton that well, the parent bone that we have want to use. Exactly. In this case is the hand, I believe. Yeah. So in the hand L, I have set up the projectile spawn. The hand L projectile spawn, and the same with the weapon. The weapon here, it has its socket right here. And this just gets the location. We just mentioned what name do we want. And I have two of these of the same code because I'm using the location of an staff and of the hand. So the location of the staff, I can get it with this code, and the notify for the hand with this node. In the end, they are saving to the same previous socket locations, to the same variable, but it's okay because I'm not spawning from the weapon and from the hand at the same time. So we can reuse this variable. But the important part here will be this plain montage notify, because that is the one that spawns a projectile staff or spawns from the L hand. Let's go back to blueprints, and I will remove this breakpoint here and put the breakpoint right here. What I'm doing is, if it's not a safe previous location from the staff, and if it isn't also a safe previous location from the hand, then the code will go to spawn a projectile. Here I just need to pass the transform, that is the location, rotation, and scale, and I'm getting this from the same node. In this case, I want the transform, not only the location. So I'm getting here weapon projectile spawn and hand L projectile spawn, and I'm picking between them, comparing if this is the spawn projectile staff. If it's the staff, then I will pick A, and A gets the information from the socket weapon projectile spawn. If it isn't, it gets the information from the hand. Here I will do a little math to get the angle between the forward angle and the direction we are getting from the calculation of the vector direction. If I could explain it better, it will probably with the animation. We have, as I mentioned, let's say that our weapon was here. So I have this location, and now the current location is this one. I have a vector that goes from the previous location to the new location. So let's draw it like this. But if I only use this direction, what was happening is that the angle most of the times was too far, which made the projectiles hit the ground a lot of the times instead of going forward. So I'm using another vector, the forward vector of this weapon, and I'm getting the angle between them. So our resulting direction will be this one. And this one has a much better result in all the tests I have done. So that's the math that I'm doing here. Just finding a rotation, making a little sums, and making the rotation. And from this, I'm passing the transform I'm gonna use to spawn the projectile. This spawn projectile is a custom event that I have created. Let's double click it. You can see custom event. If you don't know how to create custom events, just right click, custom event, and you can call it whatever you want. Here I'm just spawning the projectile with the transform. I just split it up, So I spawn the projectile, and then I'm doing a setup to ignore the other actors of projectile. So you can see more of this code later, but let's disable it for now, so you can see what happens if I don't use it. Let's resume, and you can see it doesn't work properly, and if I spawn 3 of them, then they are colliding between them, and that's not what we want. We don't want the projectiles to collide with themselves. So what we're doing here is, first, I don't know if you can see let's delete this just so the execution nodes is clear. First, I'm doing an trace, a multi-sphere trace. If we want to debug it, we can put here for duration, press play, and this is a trace I'm doing, this little sphere. And what it does is checks with what objects the current projectile is colliding. And if it's a projectile, then we're setting an set ignore actors in the projectile it collided and with the projectile we just created. So that's why this projectile, this reference, is going through these pins and setting the ignore actor here and setting an ignore actor for this one. Oh, let me see. Yeah. So what I'm doing is I just created this projectile. Now with the trace, I'm checking if other projectile exists. If this projectile exists, then I will set the ignore actor of this projectile to the one I just created, and the same for the other. That is one of the best way that you don't really need to change much of the collision settings for these projectiles to work with it. And also I'm setting that ignore actor to itself, to this character blueprint, so whenever I spawn it, I don't have problems with colliding with these characters capsule component. So that is what this code does. Just, it's a multi-sphere trace for objects. I am getting only world dynamic because our projectile is using a word, it's from the type of world dynamic, and I make an array, so I'm ignoring all actors that are from this projectile and from itself. So that is why this ignore self is here. And lastly, this, after I have set up all the ignore actors, then I'll set up the homing location. Here, this is a function I created in the projectile blueprint, but I have created also set homing actor, target component, or location, so you can specify not only a location but also an actor. That this is the almost the default behavior. The default behavior is the component, but it also works with these other functions I created. Here we just passed, we just get the distance from the actor location. So this would look something like this. If our actor is here, we're getting the location, that is this value, and I'm adding it the actor forward vector. Let's say that the actor is looking this way, and this is a direction vector, so it goes from 1 to 0. Here it will be x1 and y0, and if I would be looking this way, it may be x 0.5 and y 0.5. Well, minus 0.5. Excuse my drawing. But with this vector direction, I'm multiplying it by a distance that it will be the target distance. It's modifiable. So let's say this is 500. This direction will grow. Instead of being from 0 to 1, it will be in this direction, because it's a multiplication. 500s multiplied by 1, 500, and by 0, it will be 0. And I'm adding it to this actor location because otherwise this multiplication and this addition will be done in world coordinates. So this sum makes it so it's relative to the actor location. And that's how the projectile is being spawned. And this projectile actor is really more simple than what I have shown, because it could be used without even setup. As I mentioned, we're using a sphere collision, a particle system for the graphical stuff, and a projectile movement. This projectile movement will have almost all of the logic. Here I have set up that the initial speed will be 400, the max speed is unlimited, the rotation follow velocity, so it rotates accordingly to the velocity. This will mean that if the arc is this way, instead of, if my projectile was a box, instead of being this way, every path of the arc, then it will rotate depending on the velocity it has. And also, it will have a project gravity scale of 0 and an initial velocity on the local space, so we don't have to set up the velocity on both of, well, on all the axes. We only just need to set up one axis and it will use the local space. After this, the only setup, the extra setup would be to check it that is a homing projectile and the magnitude that the projectile will correct itself. If we were to lower this, let's say to 500, let's press play, and it will not correct itself so fast. You can see that some of them misses the target. So that's what I'm using here. You can tweak it if you want. And for the blueprint part, in the event graph, we're just setting an ignore actor of the instigator. In this case, whenever we spawn the projectile, we're setting the instigator to self. The instigator is just a term for the pawn responsible for the damage. In this case, it will be this character. This just tells the blueprint to not collide with the character that spawned it. And this set ignore actor just gets the actor and it tells the sphere to ignore this actor when moving. This is the sphere that we're talking about, and it's just a setup, so we are ignoring it. This way we don't need to mess around too much with the collision presets. I'm using a collision presets that Unreal uses. So in the tick, this behavior will stop the homing behavior and set a lifespan distance. This is pretty simple. What it does is, whenever it reaches the target, in this case that sphere, the projectile will stop returning. Otherwise, if we disconnect it, and let me disconnect only the, no, The debug code is fine because this draws that sphere. Oh, it collided. It collided again. Let me go here where it will not collide with anything. If we remove the camera, I lost it. Sorry. Let me spawn more of them. So what this will do, and I hope it will be easily seen here, is that it will make the projectiles try to return. So to avoid that, I'm setting this location that was the homing target component that we set up every time we create this blueprint, and I'm checking if the distance is inside of the threshold I have set up here. That in this case, this is a threshold. I could increase it, for example 400, and in the debug code you will see that the sphere grows. I could put it a little larger, and now it's easily seen what the threshold is. So you can play around with this value. And when it's inside that sphere, we just tell it to stop being a homing projectile and set the lifespan to a value, in this case 2 seconds. This lifespan already comes with the Unreal tools that the actor has, so you don't have to define it or anything. Just setting it is more than enough. And that's all of the code. This part is really simple. Do you know what this part does?
It's just telling you when the particle needs to die, right?
Yeah, by telling the projectile here to destroy itself. We're calling this exactly to manage to handle the spawning of the heat particle that you did. Here it is in all its glory.
It's not finished though.
Yeah, it's development. Yeah, don't worry about it.
Okay.
We spawn it, and then we destroy the actor. This emitter is independent from the actor, so I'm setting it to auto destroy. Otherwise, it would loop, and even though we can't see the emitter, it would be still in the map. So don't forget to check this. And that's it. That's everything you need to know about the projectile system that will come with this asset, this cleric asset, whenever we release it. So did you find it interesting at least?
Yeah, and you have to make more because it's complex. At least for me.
Yeah.
You need to make more. It was nice though. It was nice.
So if you want to know more about it, let us know in the comments, so maybe I could go a little more in depth. This has been an overview, and I hope that you will find it useful. So see you next time.
See you.